Okay, next important topic is handling missing data. Okay. And this is where we're going to use the updated EX4 because I added a new column. I put some missing values in there so we can look at how to deal with the missing values. We already in chapter 6 we talked about how to read missing values. If missing values have been coded by a particular in a particular way, if it is a blank, blanks will be automatically read in as a missing value. But if the missing values have been coded, like sometimes age is coded as 99 as a missing value. If you don't have age, you put just 99. Some people do that. You don't know where the data is coming from, what they have done, and sometimes that may be the case, in which case you have to read such values as a missing value, and we did that in chapter 6. If a particular column has a value used for missing value, then you use as NA missing, as you give it a list and then it will be read in as missing value. But now the question is, okay, let's go ahead and read the data in, and Pandas uses np.nan as what is called a sentinel value. So it's automatically read, blank will be automatically read in as an np.nan, and np.nan will be displayed as uppercase N, lowercase a, uppercase N. So what this means is there is a missing value at this location. Okay. So for text variables, none is also read in as a missing value. If you have none, that will also automatically come in as a missing value. Okay. So these are the missing values. So now the question is, how do you determine how many missing values there are and what to do about it? Okay. This is a very important topic in data preparation. Okay. The first thing to do is to figure out how many missing values are there for each column. So this is the code, okay, df2.isNA is going to convert the entire data set into true or false. Okay. So if you take the sum out of there, you'll see that this is the entire data set gets converted into true or false. Remember, true has the numerical value of 1. False has a numerical value of 0. So true means it is a missing value. False means it's an okay value, it's a good value. So if you sum each column, it's going to tell you how many trues there are, because trues will be 1, false will be 0. So if you sum each column, it's going to tell you how many trues are there, in other words, how many missing values there are. Okay. So that's what the sum does. Okay. IsNA, and then if you do sum, it's going to tell you how many missing values. So V1 has 3 true values, which means 3 missing values. 3 missing values, 5 missing values, 2 and 2. Okay. Now, sometimes you may want to know what proportion of values are missing. Okay. If a column has mostly missing values, sort of 50% of the values are missing, then maybe you should just get rid of that column. It's not going to be of much use to us in terms of analysis. So it may be useful to look at the proportion of missing instead of simply the numerical number. Okay. So here, if you take that sum, so it's going to give you how many missing values, and if you divide by the number of rows in df2, right? LEN df2 will give you the number of rows. So So there are 13 rows. So it's going to divide each of the number of missing values by 13. Okay, then I'm rounding it to 2 decimal places for us to be able to read it easily. Okay, so it's 23. We can even multiply by 100. Okay, make that to 4 decimal places. So 23%, 23%, 38%, 50%. So then you can decide what to do with a given column. If there is too many missing values, well, maybe it's a good idea to think about why that is, and maybe there is a different column of data that can replace it, which does not have as many missing values. So at this point, it becomes a domain area question. Okay, what to do if you have too many missing values? Okay, so this is how you will see where the missing values are. Okay, so that's about the column. Okay, what about rows? You want to look at the rows also. How many missing values are there in each row? So in this case, now you start summing. In each dimension, you sum the columns. Okay, this way. So x is equal to 1 will give you how many missing values are there in each row. Okay, obviously, if a row contains mostly missing values, once again, you can get rid of it. Okay, and for that, again, we want to look at the proportion of missing values. Now, proportion of missing values, when you look at each row, the denominator is not length of df2, but the length of df2 columns. How many columns are there? So that's what this is. Okay, so it tells you what proportion of values are missing. Okay. Then you can then say, all right, you can even make this into a condition and say in each of these, how many are greater than 50%? To get an idea how many missing values there are in the data. Okay? All right. So now we're going to use this data set in this for the rest of the chapter for your turn. Okay, and this should be already there in your data folder. It comes from this website, and it has lots of columns, but I got rid of some of them, so we will have a manageable number of columns to work with. Okay, so first thing, we're going to read the data into okay, so DFQ2 is PD read read CSV, right? And make sure that you give the proper folder path, horse small dot CSV. Okay. Okay. Now DFQ2. Okay, let's do an info after that to see what we have. Okay, so as you can see, this one has 299 rows of data, and the info tells us how many good data are there in each column. So you can see that except for the first and the last, okay, the rest of them have some missing values. Right? Okay. Are you able to read the data? Everybody? Good? Okay, now how do you determine how many values are missing in each column? Column is quite easy. So is NA is going to convert everything into true or false, and then sum. So that's going to give us the number of. Right? So that's part of A. Now, if you divide that by the length, right? So you divide that by length of DFQ2. Right? Then that will convert those number of missing into proportion of missing. Now this is for each column, and for each row, again, the first part is the same, because all it does is the is NA, all it does is it converts the data into true or false. Now, if you simply say sum, it's going to sum by column, but if you change the axis to 1, then it's going to sum each row, okay, columns of each row. All right. Now, of course, if you want proportion, then you have to take that and divide by not the length of DFQ2, okay, because when you are going across the columns of each row, the number of columns is the length. So DFQ2 dot columns. Okay, so that's going to give us the proportion of missing in each row. Okay. All right. Now C, it takes it one step further. How many rows have 50% or more missing values? Okay. So how do you do that? Okay. Now this code okay. So this code generates that, right? This is the proportion of missing, okay, for each of those 299 rows. Okay, now you want to know whether 50% is 0.5. So if I put a condition here greater than or equal to 0.5, then it's going to check each of these and then return what? True or false. It will return, is this greater than or equal to 0.5? If yes, then you'll get a true, otherwise you'll get a false. So if you run this, you'll get a bunch of true or false, right? Okay. Now we want how many of these rows have more than 50%, right? So if I add all of this up, then you'll know how many are more than. So to add that, then I need to put this in parentheses, and then I can say sum. Okay. So this true or false, once again remember, true is 1, false is 0, so it's going to sum trues will come in as 1, so it's going to give you a count of true. The sum will give you a count of true. So there are 20 rows with more than, at least 50% or more missing. So that's not a very good situation. If you drop missing values, then you're going to, off the top of the bat, you're going to reject 50% of the rows are gone now.